On the 13th of September 2011, we arrive in the afternoon of the second day of the shutdown period at Brakspruit Bridge to find the Purway crew hard at work disassembling the track to make way for the removal of a temporary bridge structure that has been in place for almost a year. Every part, bolts and clip is meticulously unscrewed and retrieved. And then the rail is cut through. The workers exercise extra caution on the bridge spans because there is no solid floor in the middle section of the track. What can be seen here is the last remaining part of a trussed steel bridge that existed here before a derailment took place in September 2010. This part of the steel span on the south side was only mildly damaged, whereas the other two spans were rendered completely unserviceable by the unfortunate accident. Hence the need for an entirely new bridge. Here in this series of still photographs, one can see the extent of the damage that the TFR personnel faced at the time. While Nelspruit Depot engineer Maroti Matebe was on site later on in the project, we asked him for his first thoughts when he heard about the accident.
At the time, it was very stressful for me. I mean, I heard about this about 9 o'clock in the evening. I was informed there's a power failure in this area. I did send a technician to go and check what's going on, Mr. John van Rijn. And then he phoned back and said there's no bridge. And immediately I was shocked. I was in a shock mode. I just wake up, had a shower, packed my bags, and I came here.
And what did
when I get here, I found out the bridge is actually down, and I got shocked. I didn't know what I must do. I don't know what went wrong. Was it? I started asking myself, was it my fault? Did I do something wrong? Something I didn't do correctly? And I was actually frustrated for a great deal of time during that day. I didn't know what to do. I was frustrated actually.
We then asked Chief Engineer Brian Monakali about the immediate and consequent steps taken.
So we had to do a temporary repairs, which was last year, October, November. So this line was off for about 8 weeks, where we're doing the temporary repairs. So what you see now on the right-hand side is a temporary structure. It's a spare bridge structure that we use in case we have sad moments like the derailment. So we took it and then we built it for about 8 weeks, as you can see. But fortunately, the span, which is on the left, on the left-hand side here, this one, the steel structure, was still remaining there. So the other two that were on the other side, they fell over. So that's why we had to put that temporary structure there. So what we are doing now, we are building the permanent bridge because this is a temporary structure. So it's a very crucial project for us it was very important for us to build this bridge within a year after the derailment which occurred last year, October 2010. So currently, there are no trains running all the way. This line goes from Palabora to Woodspruit and then transport rock phosphate and magnetite all the way to Richards Bay. This whole line is down, and we made the project to build the permanent bridge coincide with our annual shutdown. We've got an annual shutdown that occurs every year for 10 days, where work is being done on the other side of the bridge and also right through all the way to Richards Bay. So it's coinciding. The only difference is that the shutdown is going to finish is going to go ahead for 10 days. But the bridge is going to carry on for another 10 days, which is about almost 20 days bridge construction here. So we're on the second day now of the bridge construction work. That work is going to go ahead for another 17 days or so.
Infra and Purway crew are pushing to get their work finished before sunset. They have promised to have the bridge clear of tracks and other temporary infrastructure before the end of the day, so that the lifting contractor can remove the temporary bridges first thing in the morning. First thing the next morning, we ask Perway Contracts Manager Freddie Herbst for an update on his responsibilities so far.
Well, at this stage for our side, we've done what we've got to do, take the tracks away. We are busy now undoing the bridge to lift it off, and that should be on schedule for this afternoon to be on the ground. And from there on, it's the guys from the bridge to start bringing the bridge closer to us.
Yeah, when I heard about the way they were going to do the installation of the bridge, I was a bit excited because for me, it's the only thing that we see on movies or something happening somewhere in the world. I never dreamed that it will be happening in my depot, and I'm happy to be part of it. I feel great to be part of such a huge project.
Here we can see the construction crew preparing the last concrete bridge span. They're doing the shuttering for the concrete form, fixing the load transferring structure to the existing bridge piers and abutments, and inserting all the reinforcing steel, while an excavator is preparing the riverbed for the massive lift crane. At the same time, a member of the Transnet Capital project team is updating the region chief engineer on some detail of their progress. Construction manager Pieter Ben van Ryen tells us about TCP's approach to the project.
The construction methodology and approach that we adopted for this was obviously to accommodate the clients. So we decided to construct the bridge adjacent to the temporary bridge that's been erected here. And it's actually worked quite well. From Transnet side, we're basically just fulfilling a support function to make sure we assist the contractor in any way possible as to prevent any delays. And at the moment, for today, we've got a big lift planned. We've got an 800-ton crane that's on site. The guys will be doing the load test in the course of this morning, probably in about an hour's time.
Meanwhile, back at the site offices, we drop into one of the daily production meetings between Transnet Capital Projects and the contractor's engineers. Every little issue is discussed with each department concerned, with corrective action being done and monitored all the time. The TCP team is the project managing contractor, and as such has to police all progress with Stefanuti stocks on a minute-by-minute basis. Peter then tells us more about the huge crane that is being commissioned here.
Okay, the crane that we've got here is a Sarens crane. It actually just arrived on Saturday, and the guys are busy putting it up now. Today they'll finish the crane completely, and they'll do the load test on the crane. Basically, we'll have the crane completely certified then as ready for use. In the background, at the moment, Stefanuti is doing the earthworks, and then also compacting that so that the crane can position itself within its operating radius. The idea is to start removing the bridge sections from the northern side, from the Palaborwa side, and then work their way all the way down up until this big truss section that's over here. The girders, the smaller girders, they probably weigh in the region of they're about 30 tons each, and the bigger one on this side weighs 84 tons. So what we've done on the rigging study itself is we've set the crane up to pick a load of 106 tons, which is only 60% of the actual capacity. So there's a huge safety factor that we've got worked out for the crane. For today, basically we've got planned to remove 3 of the bridge sections, and then tomorrow morning to remove the last 2, with the biggest one that we'll just put over here. We're busy excavating now, and we found a shallow rock next to pier number 2, but we've got quite a few options there. A 140-ton crane came with the big 800-ton crane, and the option would obviously be just to use the 140-tonner. Then the 140-tonner will stand in between pier 1 and the abutment, and it will do the lift for us. But the rigger is quite confident that if he moves the train right up until the rock, he'll just double-check the radiuses again and go back to the load chart and just confirm loads. First choice would obviously be just to use the bigger crane, because then we can pick up momentum from there and just work our way back. It'll take a little bit of extra time to set the other crane up. But according to the program, these lifts are only scheduled for tomorrow, so we're actually running a day ahead of schedule. If you can remove any bridge sections today, it'll be good for the program. It's obviously Transnet is losing every day that the trains are not running over the bridge. There's a huge amount of revenue that's generated, and that's why there's a lot of pressure on the guys to maintain and stick to the window that the shut's originally planned for. On the 30th of this month, the bridge must be opened again, and we're expecting the first trains to cross here on the 3rd. At the moment, there's a lot of pressure, especially on the Stefanuti guys. They need to complete the new bridge almost in record time now. There's a huge amount of pressure on them. They working around the clock, 24 hours with night shift teams that's coming in to see to ensure that they meet the dates that's set for them. So a decision was made to construct a concrete deck, which is what the guys are doing in the background now. As it is right now, they're constructing 3 concrete decks, and they're going to stitch these decks together. And then once it's a continuous piece of 98 meters long, it'll be launched across from its current position. It's constructed obviously on a temporary support structure, and it's got launch beams that tie into the abutments and into the new corbels that's been casted on the 2 piers. But what makes this launch slightly unique is the fact that it is a side launch. A lot of the other launches are not incremental launches, but so I don't think you're going to see too many of these launches in the near future, and it's quite a unique and interesting project to be involved with, both in the beautiful area that we are in with all the game that we have got around us. So nice to be part of this.
Brian Monakali then talks about a very important issue for Transnet Freight Rail.
Most importantly is safety. As I've said, this is a very, very complex project. Involve a lot of sub-teams within, subcontractors within. So it's a very complex project. So safety is crucial. So we're taking it very, very seriously on site. I'm sure you might have noted, this site is ring fenced all around. There's a fence that is built all the way. There's no one who can have access to this site, right all the way. There's no car that can come and pass through. There's no person that can come and pass through. And you've got a gate there at the top end there. That's where everyone can come in. And then when a person comes in, there's a security team there. There's a safety people there that you can see when the person comes in. And then he goes on site for induction. We make sure everyone has been inducted before you come to site. And also you sign that you understand what you've been taken through. In addition to that, every morning there's a safety talk. Every morning before work starts, there's a safety talk that gets done by the teams before work is started. And at 11 o'clock every day, there's a teleconference with all the project teams involved, also obviously including the people on site, whereby they gather and talk about how have things been going over the past day up to just before 11 o'clock of the day. And then whatever problems we encounter, we resolve them immediately so that they don't affect safety and also they don't affect the program. Because we cannot afford to come the 30th and we cannot give the line back for the customer motions operations. So we have to make sure that we are on target, safely on target, on daily activities. Because come the 1st of October, we need to make sure that the trains can run here. Because it's a big loss to the business that we are standing here busy with the repairs here. So it's such a crucial project.
Progress with the crane is slow and deliberate, with every part involved being a super-sized component. We leave the site that day while work continues into the night. The access roads to the construction site are shared by landowners who maintain and operate nature reserves. The passage of vehicles and animals is monitored carefully to prevent the loss of game through theft or disease. Aerial tracking of game is a frequent and necessary activity. This track makes its way through some beautiful bushveld scenery. Once on site, we interview Bruce Ivans, Stefanuti and Stock's senior site agent for the project.
Yes, basically we're building the new bridge that we're going to be sliding across. So pretty involved with that. A lot of concrete involved in getting it ready, a lot of prep work, a lot of support work that's gone into that as well. It's logistics, truck in and out, access roads also restricted. You've got to plan your loads very carefully as to what comes in and what goes out, when it comes in and when it goes out. Basically a truck, it can vary between 6 and 8 cubes our delivery. Our paws range, our smallest paws being 30 cubes, which takes about 5 trucks, 5 to 3 trucks depending on the size truck that they were using. The bigger pours that we're doing is up to 130 cubes. And 130 cube pour, you're looking at a minimum of 17 trucks in order to do that pour. And that can go, we've had some pours that have literally taken 12 hours to do. Been remote, far away from site, etc., with breakdowns, etc. Otherwise, yeah, all in all, we look in the region of about 150 trucks of concrete coming in here. Maybe close to 200, it just depends how it's structured, but generally our whole job's over 800 cubes of concrete. Basically what we're using is it's a lot stronger system. It's a super short system, proprietary system from Formscaf, and a unigirder system on form shoulders. It carries a lot higher load compared to your quick stage conventional way of building it. It's the first time the team that we've got here has worked with that type of equipment, being the super shores, and we've used super beams and other bridge applications previously. They work quite well at spreading quite large loads. But in terms of the super shores and the form soldiers, that's the first time using it, is quite unique. And Formscaf did the design for us on that as well. Some of the things very, very tight, short lead period. Steel strike didn't help us at all. There were a whole lot of angle braces and stuff that were being manufactured at the time. And due to the steel strike, they couldn't get the 70 by 70 angle that was required. They came up with another plan to give us some scaffold tube as an intermediate so that we could just carry on and erect. Obviously that had to be replaced, and we got some additional hands on board to do that. But yeah.
Satish Ganesh is Transnet Capital Project's Senior Project Manager on site. He briefly explains what has happened so far.
What we have done is the existing both abutments on the north and south concrete abutments and both the existing piers were strengthened to accommodate the new loads distributed by the new concrete bridge that we're going to push in place. The involvement of our own engineering, TCP engineering involvement on the project, they were responsible for the design work, for the rail, the OHT and the signalling. Together with our own in-house RME construction division, they are responsible for the construction or the removal of the existing purway work and the reinstatement thereof. They have completed successfully thus far the removal of the purway stuff, and they have to reinstate it at the end of the occupation. Well, we're on day 3 of the occupation. We were scheduled today to remove the existing temporary bridge spans. We're planning to start now on the north section to start off. We had a few delays on the setup of the crane, but we sorted out and we're ready to go.
There is constant activity around the crane. So, as soon as we get a chance, we ask Peter for an update.
Okay, look, what we're going to do now is the Sarens crane has basically been set it up. So it's ready to do the load test now. The load test has been completed for 60 tons. We've got the paperwork all here. All those orange slings are uniquely numbered. Those are 100-ton slings, nylon slings. They cost about 90,000 rand per sling. And then we've got shackles and we've got chains that we're going to be using as well. All the certifications here now. So we're just going to do a quick check to make sure that everything is in place before we actually send the guys up to the top to go and sling the girder so that it can come down to ground level. So what we've got here is a hook certificate. So these are certain parameters that the crane hook itself needs to comply to. So there are certain dimensions that needs to be taken, and obviously it gets signed off once it's been inspected. So this is just proof that the hook and stuff all in good condition and good nick, and it complies to the latest regulations and measurements are all fine. This certificate is a rope inspection certificate for the 400-ton crane. Also up to date. It's just recently been updated and inspected.
Okay, and the next one.
And this specific one is for the load testing of the crane. This was just completed yesterday by an LMI inspector, basically giving us the go-ahead now to proceed with this lift.
Bruce Ivans tells us more about the crane and its operators.
With the big crane from right at the beginning, at tender stage we planned on using Sarens. We've used them before as a company, Joburg and down in Cape Town, and they're very reputable. They've got good equipment, and yeah, they've set up their logistics in that. And with the shut or the furnace that blew at Mittel, we've got a little bit bigger crane than what we originally anticipated. So yeah, bringing that on board was quite fun with 20, close to 30 load beds up and down the road over the weekend, bringing all the bits and pieces in. Basically, we're in a position at the moment, they're just doing the final load checks, final radius checks to lift off. They're going to start off with the smaller sections, and then we've just got to finish off a platform on the southern side, and from there we'll be going in to do the bigger section, or the truss bridge.
The Sirens riggers are very careful and execute their tasks in a deliberate, unhurried manner. Slowly but surely the chains are wrapped around the temporary bridge spans. Then the guide ropes are manned under the direction of the master rigger, and the sense of anticipation grows in this, the first lift of the sequence. Eventually, as the tension is slowly taken up by the main pulley, the bridge gets liberated from its footing and gently floats into the sky. Over the next day, the remainder of the temporary spans, as well as the heavier old steel truss span, is lifted off the piers. Back on site some days later, we find special anchor blocks being lifted into position on top of the piers. Later, once these are bolted and grouted in, these will be used to pull the bridge onto the pier's permanent bearings and support structure. Holes are being bored through the pier to facilitate special divvy deck bars that will be tensioned to bind the core bolt or load-bearing platform onto the pier, causing the weight of the bridge to pass efficiently down the main pillars to the bedrock. The site is frequently visited by project leaders who keep tabs on progress and assist the contractor as much as possible. Time passes by as everyone tries to work as fast as possible. We get an update from TCP's construction manager on some critical path activity.
Yeah, look, I mean, getting closer to the launch now, we're obviously still sitting with a few critical path activities that need to be completed. One of the major things at the moment is to complete the stressing of the cables on the deck spans that we're standing now at the moment. This span number 3, the stressing's been completed, and you'll notice at the back here the guys are busy putting shutterboard out, and you'll see a piece of black pipe sticking out there, which is the grout pipe. So what they'll do is they'll pour that shutterboard to close the end cap of all the stressing cables, and then actually force grout through that little grout pipe. It's got another vent pipe way on the other side of the deck, so you'll pump grout through at a pressure of 10 bar with a certain flow rate to make sure that you get all the air out. And as I've mentioned, there is a vent pipe on that side, so you'll actually fill the entire stressing cable completely with grout. So you want any air to be trapped in there, and that's, like I said previously, you use a pressurized grout pump at a specific flow rate to make sure that you get the right amount of grout at a certain pressure, just to push all the air out of the cable ducts and get a perfect bond. So you'll see there's vent pipes on the other side. It can be a bit of a messy story, because when you start pressurizing and you get air escaping on the other side, you'll get a bit of air and grout coming out at the same time. So guys will have to stand clear of that area, and there will be a bit of grout that needs to be cleared up afterwards as well. And once that's done, the process will basically be continued on the other spans as well. As it is now, that grout inside the cable will have to cure as well. So it is a process that's really critical to the launching of the bridge. It actually forces this whole bridge together and it makes it a complete unit. You'll also notice underneath the piers, there's those bearing pedestals that's installed, and underneath each and every bearing there's 3 of these divvy-deck bars that go through. And those divvy-deck bars, they get stressed as well. They get stressed up to 580 kilonewtons. And same thing there, it basically forces the loads together, and it actually directs it down into the center of the pier. So those corbels don't just carry the load now right on the edges, that whole load's been transferred into the column, and it makes the whole corbel and the existing pier a unit, so it can spread the load and carry it much easier.
There are other jacks being used for tensioning the cabling system that is inside each bridge span. Peter tells us how that system works.
So that big jack that you see is a jack that can basically stress up to, for these cables, needs to be stressed up to 2,900 kilonewtons, and that's for the 15 strand cables. Then there's 12 strand cables as well. They get stressed up to 2,300 kilonewtons. What the guys will do is they'll use that stressing jack and slide it over the cables. You'll see it's got a backing plate that's got a whole lot of little cable grippers on the inside. And as the jack starts pushing, it actually causes these grippers to attach hard onto the cable. You'll do it in increments of 5 megapascals at a time, or 5 MPa, and then take measurements. So every time you actually stress, you take a measurement to see exactly how much the cable has been tensioned, and that obviously gets then tensioned up until it's 50 kPa, MPa. For the 15 strand ones, and 43 MPa for the 12 strand ones. It all goes onto a graph, and it gets all plotted out, and there's E-values that gets calculated. So far all of these ones has been completed, has been released now, so at least the 2 spans that's been done has been found to be acceptable, or they comply to requirements, and the guys can now proceed with the grouting. On the concrete itself, this concrete is early strength concrete. The FAR's actually developed a special mix design for the Brakspruit brug, because we're getting concrete from the Hazyview plant, and it actually takes those concrete trucks 3 hours to get here. So this is a special mix. This is a 6-hour mix design. So by the time that the concrete gets to site, you've basically got another 3 hours left to work with the concrete and make sure that you place it and flatten it out or float it before it starts becoming almost unworkable. So most of the slumps that we get here is about 140 to 180 slump, which is very nice for using the concrete pumps. On hot days, obviously like today, you'll find that those 6-hour mix design comes down to about a 5-hour mix design, and the guys will have to be a bit quicker then. When the concrete is below 120 slump, it becomes difficult to pump it, and we'll still allow the guys to use buckets. But if it's less than 110 slump, then you can't use the concrete anymore. The slump test is basically something that you use to determine the workability of the concrete. When they do a mix design, then obviously they'll specify a certain slump as well, and that concrete needs to end up within certain parameters. So when the concrete trucks come to site, we'll do a slump test on site. That basically involves almost like a conical metal sheet that's been filled up with concrete. That gets prodded with a 20 millimeter rod for 40 times. Actually, they fill it up in 3 stages. So there's a specific procedure to that. But at the end of the day, that'll actually be pulled off, and the concrete will settle down. And you'll actually measure from the top of this conical metal sheet down to the top of the concrete, and that'll determine if it's very flowing. It'll be obviously a larger slump, and if the concrete's not so workable, the slump will be a lot less. So that's basically how you determine it. Okay, the guys at the back of us are actually repairing the ballast retaining wall. When there was a derailment in September last year, one of the wagons knocked the entire ballast retaining wall out here. So now the ballast is basically falling down the abutment. So the purpose of this wall is to retain the ballast, and the guys are busy doing the shuttering at the moment now. They have ordered some cement for tomorrow morning. So the idea is to pour both this northern abutment and the southern abutment in the morning, and then give it a bit of time to cure, and then basically backfill at the back of the abutment. And I can see this probably being completed by about lunchtime tomorrow. The ballast retaining wall that the guys are doing over here is not critical for the launch. That's something that can be done at a later stage. For the launch itself, now obviously the stressing cables, the grouting up of the stressing cable is really critical. When they stress the deck span, it actually transfers the weight from the superstructure that they've got at the bottom onto the launch beams. And that whole unigirder support structure needs to be lowered by about 10 millimeters just to make sure that it doesn't touch the deck anymore. If it's not lowered and you start launching across, that entire support structure will move with the deck. And that's quite a long process. The guys started lowering the span number 3, the one that we're standing on now at the moment. And obviously they've just been given the go-ahead now to do the same on deck span number 2 since they've completed the stressing on that side. After that it's still the installation of the launch equipment. There's a lot of the launch bars that must be installed. There's quite a bit of construction activities at the moment, so there's some launch equipment in the sense of hydraulic power packs and pressure gauges that must also come up, but I think it's still a little bit too early for that. Those are the last things that you install. The idea there is to have the central power pack installed on the deck span on the bridge itself. There will be 6 jacks that will be operated from the hydraulic power pack for the launch. So it's all that equipment that must be set up as well. There's quite a bit of grouting that must be done on top of the piers. There's some of those launch beams that needs to be secured and bolted down properly, and those nuts needs to be torqued up nicely before the launch can start as well. And then some last minute things that the guys are doing on the deck that's also quite crucial to the launch. But a fair amount of work still left, so I can't see the guys moving the deck tonight, but there's a lot of preparation work that can go into it to get it ready for a launch during the course of tomorrow.
It is extremely important that these stressed cables all share the load equally, thereby supporting the bridge across the entire structure. That is why a record is kept of the whole process, just to be sure in every case. The safety of the entire project is uppermost on TCP's mind, so we speak to Bekeni Msebeni, Richard Bay Corridor's safety manager, on site about his experiences so far.
It's crucial because of the high-risk activity that we are facing. Most of the people are working at height. So we've a little bit compromised on safety. I would say with regards to the hand railings, it's like some of the guys needed to be mentored and coached with regards to wearing their safety belt, but it was supposed to be a standard practice because we are having a DSTI in the morning just to address. Is like DSTI is risk-based, so where we identify all those risks and try to come up with some mitigation. As TCP, we're trying by all means to support them. With regards to the documentation, it was up to scratch because we have to went through to all this risk assessment, method statement before any task can commence. With regards to the overall incident, it's like I would say it's like we were lucky because we didn't have any lost time to date. We had a couple of, I should think, first aid cases, about 5 first aid cases. We had 1 medical and 2 MVAs. So we haven't had any fatality and lost time injuries.
Mainly just hand injuries. If identified the root cause, it's just been poor communication between team members. Because the team started growing so quickly, I feel that the team members weren't that familiar with each other. And often guys from Natal and guys working up here, there's a little bit of a cultural difference and a communication barrier as well. So we worked quite hard on that and got the guys to work together as a team. But areas where you can improve is obviously the overall safety culture. To make sure that from management safety is driven down, it needs to filter down into the workplace so that the guys on the floor basically, making sure that they're working safely. So yeah, we've employed additional guys to assist with that. And then basically just drill down. If we see guys not wearing harnesses, because obviously working at heights is a major thing. So there was specific attention given to working at heights training and safety belt training. And yeah, at the end of the day, I think statistics speaks for itself. Like we said, the guys have done well up until now. 65,000 hours without lost time injury is a good thing. And I mean, from here we want to promote it and see if we can make that figure grow. We want to definitely finish the project off on a high note with regards to that. So we'll support the guys wherever we can.
OHTE and Purway teams are not sitting idle in the meantime while the bridge construction is happening. They are staying on track so as to be ready as soon as access is granted to the bridge. New turnout and points are installed and aligned in the meantime. On the other southern side of the bridge, the old temporary bridge girders have served their purpose well and are being placed back on 2 wagons to take their journey back to storage and emergency standby. The next day, management teams are focused on the nitty-gritty detail of how to keep this project on track for their deadline. It is a constant battle juggling labour and resources and overcoming the minute-by-minute challenges. While some activity is focused around the load transfer structure and skid beams, we have a quick word with site engineer Clint Green about his task for the moment.
Actually, this is called a skid beam. I've used a dumpy level to take the level of the underneath of the bridge. So that bridge comes along and it slides onto the actual skid beam cross. What we're standing on there at the moment, it's called or if you have a look right in the corner, that's called a permanent bearing. We move the bridge across on the skid beam and we jack it up and then we place it back down onto the permanent bearing. Well, we're working towards a 1 millimeter deviation. So what I've actually done is I've taken a level underneath the bridge and I've transferred it onto this. So from there it's 1 millimeter off. Yes, what happens is if this is higher than where the bridge is, it increases the friction. Therefore it makes it harder to push the bridge across.
High up underneath the concrete spans, workers are disassembling the platform that was the base of the concrete when it was cast. One by one, each sheet of shutterboard is passed down safely to the ground. As the bridge has been tensioned, it has released some of its weight off the shutterboards. So now they are removed so that they will be completely out of the way once the move begins. One can clearly see from this edge how much the support structure has been lowered. The view from the kopje across the site shows more water being hoisted up to the deck for the grouting to continue on the remainder of the cable cavities. This young impala seems quite unperturbed by all the activity while she browses for the best new shoots in the dry Brakspruit riverbed. Workers continue to release the shutterboards all around the base while new hydraulic hoses are being laid out in preparation for the horizontal jacking procedure. Construction manager Peter explains the process further.
Okay, now it's going to be hydraulic cylinders that will be used. There will be 6 in total. There will be 1 at each pier, or 1 at each abutment, and 2 at each of the piers. You can see on top of the pier is a big beam that's located, and there's 2 bars that's going through. So those bars go through underneath the deck, and then they actually tie up into a big beam, and on the back side of that beam you'll have the hydraulic jacks. So these are hollow jacks. This threaded bar will go right through the jack. Basically, when I energize the jack, you've got a centralized hydraulic unit manifold sitting on this side here. So each of the jacks can be controlled individually. There's pressure gauges on the jack, and you'll actually be able to see exactly how much pressure you've got on each gauge. And they'll also have a launch operator at each and every one of these jacks. They will be equipped with radios and also air horns. So they've got specific functions. They need to monitor those specific jacks and just make sure that the launch path remains clear and nothing's in the way. The operator at the top, he will basically monitor all the gauges and will have a visual contact with all of the launch equipment from the top of the deck here. So basically the jack will be energized and will extend up until it reaches maximum capacity. The pressure will then be released completely and the jack will be pulled back. And at the back of those bars, that lock nut will be tightened up all the way again. And simply the jack will just be extended again until it reaches maximum capacity, and that process will be repeated. Now, as you can imagine, there's quite a lot of pulling forces against the pier. So, because you're basically pulling this bridge into position. And there's some surveys that will be done on the pier just to make sure that you don't get any deflection. So I'll have somebody standing at the south abutment, and we've got points that we'll mark beforehand and determine the exact position of the pier. Then when you start jacking and the pressure reaches 5 MPa, you'll actually stop the process, go back and see whether you've picked up any deflection on the pier. And we've allowed for like a maximum of 5mm deflection. If it's 5mm, and it's still acceptable, and the guys will carry on. They'll then carry on until they reach another 5 MPa. If the launch process just remains, below, say the 10 MPa, because you're going 5 MPa intervals, then we'll just carry on. But obviously, if you get into a situation where we see that a pressure gauge gets to a pressure that's closer to 10 bar, then we'll stop and obviously have to see exactly what's causing that additional friction. But we're obviously not hoping that something like that will happen. The whole launch beams and everything's been prepared nicely and to the drawing, so not expecting any problems like that. As it is right now, the bridge obviously been surveyed beforehand, and as it is now, nothing's in the slide path. It's standing 100% parallel, so it can basically just from here, it must just move exactly over into place. And obviously with the launch jacks, you'd be able to control movement, and if you get into a situation where you need to accelerate on the one side slightly, you would be able to. But there's also launch beams and guide beams that's being installed. They're still lying on the deck over there. Those are those big yellow beams. There's some of them that's been fitted on the front of the pier here. So as the bridge gets pulled closer, those guide beams will actually guide the deck into position, and it will keep it central to the piers and to the abutments. They've also installed a stopper block. So when you jack the bridge, you basically jack it up against the stopper block, and if it hits the stopper block, you exactly center to the rail lines. Look, on top of the launch beams, there's a special machine plate that's there, and that's lubricated with just a grease. On top of that, there's like a polyethylene liner plate that's got a very, very low friction coefficient. And that's basically what makes up your launch mechanism. That's already installed even before the guys installed the shutters. That was some of the first items that was installed. So the concrete deck was actually cast on top of the launch beams with all that installed. There's still a little bit, obviously once they've completed the installation of a small portion of launch beam on this side, that must be lubricated as well, and so that those launch pads can basically just glide over the remainder of the launch beam until it reaches its final position.
The hydraulic inner pack operator explains the detail of their technology to all parties concerned as night falls on the scene. Our time-lapse cameras capture the activity over one of the piers and the bridge view from the southern end at the end of the day. The next morning there is a buzz of activity as the final preparations and cleanup is underway. There is mounting tension among the management as they struggle to stay within their committed deadline. In this instance, the continuous hole that needs to be drilled through the entire width of the bridge for one of the pulling bars is giving problems, and the drill bit is getting blocked from time to time. Without this hole completed, the jacking equipment cannot be fixed and made ready. In the meantime, all other jacking equipment is in place and final touches are made to the guide beams.
The arrangement will be the bridge, but I don't have an update.
Back at the communications caravan, the daily teleconference participants hear about progress and problems on site from depot engineer Maroti Matebe and infrastructure manager Chilidzi Munyai.
The bridge is still not yet launched onto their pier, on top of the piers. We are still waiting for the contractor to finalize the challenges that is currently experiencing. As soon as that is done, we'll also be able to communicate with you accordingly. I would like to officially declare this telecom closed. And goodbye, and remember to work safely.
Infra workers are now able to work on the bridge and start installing overhead track equipment pylons as fast as they can. At the same time, their colleagues offload and arrange sleepers to be ready for deployment to fill the gap between the track and the bridge. The drilling work on the remaining holes still continues, while more and more loads of unwanted material is removed off the bridge. In preparation for the launch, Stefanuti and Stocks engineers begin to evacuate the bridge of unnecessary personnel, and the launch contractor quickly clarifies the running order of events with second-in-charge engineer. At the same time, the skid beams are cleaned again and again to make them as smooth and as slippery as possible. Anticipation grows as more and more checks and cross-checks are done. Everything is now ready. Cameras in position. Air horns and radios are distributed to relevant workers.
It's an extremely technical feat. I'm sure we're up to it and everybody's going to perform well, eh? But best of luck and let's go and do it, eh?
Now,
thanks.
you can sing the national anthem.
A pre-launch meeting is then called for everyone to be briefed on their role and rules of procedure.
Every 10 millimeters on time when we measure, can you give one short burst on your horn? If there's any problems anywhere, you must give one long burst. If anything, especially clear, Clint, with the pier deflections and so on, if the pier starts deflecting by over 5 mils or so, then scream. So, guys, with the radios and so on, please, if no chatter on the radio and so on, unless there's you're communicating to me or Clive, please.
Or myself.
Yeah. And when we ask a question and so on, if everything's going okay and so on, it's a clear yes or no. If it's a problem and so on, use your air horn. Because I'm standing in the middle of the deck here, I'm not going to hear. I might not hear at the south abutment and the north abutment and so on.
10 mils?
10 mils is just a quick one.
The sample of emergency. That's for the emergency.
Yes.
Okay. But the rest of the guys, once you're in your positions, I'm going to go through and double check that everybody's there. I will give Ludovic the all clear that everybody is in the position and everybody is off the deck that is not supposed to be on here. It is a major safety risk to have people on here that don't need to be here. Okay, you're on a static structure at the moment that's moving, supported by towers. So only the people involved on a launch will be on here. Okay.
May the grace of our Lord Jesus Christ, the love of God, and the fellowship of the Holy Spirit be with us all now and forever. Amen.
After a brief prayer, everyone is briskly off to man their stations. Last-minute walkway railings are removed. All theodolites are fixed to their angles of view and ultra-precise measurements. The bridge is finally freed of its most frequented stairway. It now stands alone while launch director Bruce Ivans starts the countdown.
Staircase is off. You can start the countdown and let's go. 3, 2, 1, let's go.
A little obstruction here and there is dealt with, and Bruce earnestly gets the jacks pulling again. Every jacking station reports the number of millimeters they have seen move. This feedback indicates how the hydraulic force should be balanced and distributed to keep the bridge nice and square to its direction of movement.
So it must go at the same time?
Yes.
Same pressure?
Yeah, everything. It's all on it. I want to do this.
The one that's linked to the, what you call it, the road?
Yes.
This view of an acute angle with the underlying shutterboard shows exactly how the bridge is moving in real time. As the day passes, we refer to our time-lapse camera to get a time-compressed view of the launch progress. First, a view from the southern abutment side. And then a view from the northern riverbed facing the setting sun and moon. Eventually at 2100 hours, the call is made to stop the launch due to poor visibility and a high wind speed across the bridge. Very early next morning, everyone is preparing to man their stations and carry out their briefs. At the bridge platform, on the skids of the launch beams, we can clearly see the distance moved the day before. It's about 3 meters. A small height difference due to settling has been detected over the launch beams, and adjustments are now being made to make the transition from one structure to the next as smooth as possible. At the same time, other formwork to prepare for the grouting of the bearings, once the bridge is in place, is also being carried out. Looking closely, one can see the shims inserted under the left-hand side skid and opposing tapering done to the top of the right-hand side skid for the levels to better meet each other. Finally, Bruce gets the launch underway again. And one can see the progress as gaps between structures gets smaller and smaller. But once again, the process is halted as the special low friction pad underside the bridge becomes fouled as it makes its transition across the gap between the skid beams. Once again, our time-lapse camera from the riverbed shows the day's launch progress. Further work progresses through the night. The next morning, it is decided to weld a continuous skid beam without any breaks at all the piers across the temporary launch beams to the permanent pedestals. Doing so will obviate any fouling of the special low friction pads underneath the bridge as it makes its move across. We leave the scene as this work is executed over the next few days. A week later and the bridge is perfectly in position and the launch hype is a thing of the past. Now it's go, go, go for the infra teams. Looking at the temporary platform, one can see how perfectly the bridge has appeared to float off to its new location. On the bridge deck, there's brand new ballast being tamped in. Signals wires are being connected and sealed, and splicing of overhead wires is underway. The last of the launch jacks is removed off of its pulling rod and block, while the infra crew prepare insulators to hoist up to the pylons. Underneath, the bridge has been jacked up so that workers can clear out the product left on the skid bar to prepare the skid for its imminent removal, so that the bridge can finally rest on the pier's permanent bearings. Above deck, the shiny new feeder wire has been uncoiled, and at the northern end of the bridge, fresh contact wire is unloaded, ready to be rolled out manually. Hydraulic crimping clamps are used to join the feeder wire sections together. These workers make sure their crimps will last for a very long time. Eventually, the contact wire begins to get tensioned up while electricians check and double-check the wiring on the points. There is a spirit of fulfillment as all workers focus on their individual duties. They can see as their personal contributions are all helping to make the plan come together in a swift and efficient manner, making true the saying that many hands make light work. Gradually, the sun begins to set on the day, while more OHTE work continues into the night, now with the use of floodlights and full-height wagons for easier access. Eventually, the moment we've been waiting for arrives. At around 2000 hours on the 6th of October, the TCP team on site hand over the bridge to Nelspruit's infrastructure manager Chilitsi Munyai and depot engineer Moroti Matebe. We witness as the necessary paperwork is signed and last-minute details to be finalized are discussed. The bridge now is finally in the hands of Transnet Freight Rail. Almost 1 month later, we pop into the site for a final visit. As flatbed trucks arrive on site to collect scaffolding, we see our first train coming up the line and crossing the bridge with empty wagons to take to Palaboa mine, to be filled to the brim with foreign-earning commodities. We film some touch-up work in progress while more trucks are loaded with the special formscuff parts that carried their load so well. Every other little piece is grouped and stacked ready for its transport. And then we get to see the glorious bridge in action one more time as a fully loaded train crosses over the Brakspruit River, carrying its valuable load to the coastal port at Richards Bay. For the construction workers here, it is just another day at the office. But for us, this is a wonderful sight of an amazing and technically challenging project where an absolute commitment to perfection has triumphed over all adversity and quite simply become a job well done at the highest level of achievement.
And the other option was to say, look, why don't we build a bridge which is, you build it on a suspended in the air, you pour concrete and everything just next to the current bridge. And then after that, then you'll need to just collapse the temporary structure and just move it across, what we call it side launching. The normal launching of the bridge, what normally happens in the industry is that they do what they call the longitudinal launching, which actually is incremental launching, so going forward. So this time around we had to do it differently, which is basically to do a side launch, where we had to move the bridge about 10 meters. I mean, we're talking about the bridge which basically tonnage-wise, the concrete that we did pour, it's about, over 100 of trucks of concrete that we had to pour. We're talking about a 100-meter long bridge. We're talking about the bridge which the height where we were building this thing suspended on that superstructure it was 18 meters high. And we're talking about the tonnage in terms of the weight of this thing at the end. We're talking about 1,500 tons. That's how heavy this bridge was. And we had a couple of challenges which hit us, for instance, like the steel strike. We actually lagged quite a lot because of that. And we had some minor challenges which are project challenges where the labor force, today you find them, they come, the next day they are not there. So, but we managed to overcome that. And I think, of course, from the support from all the stakeholders, it worked very well. So the launch, which was scheduled maybe for a day or so, it took even 4 or 5 days. But I think it was a very critical thing to do, an important thing to do, to make sure that we don't jam the bridge. Because can you imagine if we had jammed the bridge, moving it back and all those things, it could have taken months and months and months. But I think we were very, very careful in terms of making sure that we don't cause any catastrophic delays, and finally, at the end of the day, we did manage to come back home. And on Wednesday, very early hours of the morning, I think it was 7 minutes to 2, we managed to push the bridge into place. And it was quite a very emotional thing at that time when the contractor moved across. I vividly remember that. He moved across and he stretched his head. He said, "Sir, you've got a bridge."
We had serious challenges as far as the completion of the work. And as I've said, this was a special project. I'm saying it was special in the sense that it's the first time that the project team that was working on this has ever done a bridge construction from scratch, from the ground, up to the required height next to an existing temporary structure. That was for the first time. I think what went wrong, which is a key learning from the engineering team in the project, is to be too optimistic. So as the engineers on the project were too optimistic, and we just thought we could be able to do it in 20 days. And everything was very tight as far as the program. There was a significant amount of work to be done every day. There was no slack that was given to say, what if things don't go well? I think the project size was hugely underestimated in terms of its magnitude. And as a result, a lot of challenges were being experienced as we go. Because it's rare that you had a bridge constructed the way it was constructed, even worldwide. So what happened? What resulted that resulted into a situation whereby now, come closer to the end of the expected construction period, which was the 20 days, up to the 30th of September, we were not ready to launch the bridge. So launching meaning that pushing the bridge into its position. So as a result, there were lots of challenges that were being experienced through that process. It proved to be very, very, very difficult than what we thought. And we later kept on postponing to say to operation the customer, we need another day, we need another day, we need another day. So another lesson from the engineering point of view is when you see things are not going well, it's important to be open to the customer and say, instead of you giving us up to tomorrow, maybe you should give us the next 10 days. And then by doing that, there's clarity on both sides. Therefore, the planning can be readjusted rather than kept on saying we will finish it tomorrow and then come tomorrow we're not done. And then we say the other day and we never get the project done. So that's one of the key lessons. When you realize you cannot make it, maybe ask for the longer period, so that if you finish a day earlier, then it's a bonus. But you need to be open. And I think also the engineers that were involved, they didn't want also to disappoint the customer. So it's more like trying to tell the customer what the customer wants to hear. Whereas you can see that there are challenges on site. So I think we failed to do that on time. And going forward, I think it's a key lesson in any project to be upfront. And if you are not sure, when you are not sure, ask for a longer period so that you get all the time to get the work done. So to promise that I'm going to finish tomorrow and you don't finish tomorrow, that's the worst one. And also, this type of incident and also construction has actually made us now to be more alert. Because as I'm talking currently, the bridge office under Johan van Aert and through Jan Homen is currently undertaking a study to look at all the bridge countrywide and see what can we do to make sure that we've got the right types of bridges and we have bridges that are also are far less exposed to risks such as derailment and even with less maintenance cost. So we're doing a countrywide assessment of those. The exercise will be finished, and then we'll launch a program to actually make differences into the types of bridge that we are having. So that's the main benefit of the project. Obviously, in addition, now the trains can run, and we are confident that the trains will be running reliably. And for about a year, whilst we had a temporary bridge, we were having a speed restriction there of about 15 kilometers an hour. So that means the train had to slow down through that section because it was a temporary bridge. You cannot go at full speed. But after the bridge, permanent bridge construction, the trains can run at normal speed, which can go up to even 60 kilometers an hour. So from that point of view, it's a huge benefit to the customer. And also, as I've said, the prevention of any possible failures going forward is also one of the major benefits. And now, lastly, there's a number of people that were involved in the project. In fact, I would say from the time we were doing the temporary repairs, RME was given the task of assisting us to do the temporary repairs when we had a bridge collapse up until the permanent construction of the bridge, whereby the project was handed over to Transnet Capital Projects, which is the project side of TCP to do the consulting and the management, project management of the whole project. So I would like to say thanks to them for their hard work. I know it was very rough, especially when the timelines could not be met. It became very, very rough, and I think the team managed to get on site and actually get the work completed at the time that was given, which was up to the 6th day, in addition to the 20-day normal shut. And also, as part of the project, we had RME again were involved in doing the track work and OHT work. And I'd like to say thanks to the RME team for the great job on site. And also the material removal or planning team under TCC and also supply chain. A lot of material was needed for the bridge construction. I would like to thank that team for assisting with that. And all the other contractors, subcontractors that were involved in the project. We had a number of subcontractors. We were also doing very specialized work, welding and so on, steel work, So I'd like to give thanks to those teams for their hard work and also working right throughout the duration of the shut, and some days working 24 hours. And also I would like to thank the infrastructure team or rail network team, which is the depot under depot engineer Maroti Matebe and Chilizi Munyai, the infrastructure manager. So I'd like to thank them for the work that they have done throughout the project, being there to make sure that we support the project team in execution of the project work. And also, most importantly, to management, and specifically Fuzile Magwa and Leslie Mapumulo, who are the leaders of the operations in the area, for them giving us an opportunity to take even more than the time that was given to us, for their patience, because they know what is at stake here. So we really appreciate that. And also the operations team that was helping us to move all the material trains, CTC and so on, and the train drivers to get all the material on site. So I really, really appreciate their support, and obviously to the EXCO, TFR EXCO, for giving us an opportunity to do such amount of work. And lastly, Johan van Aert's team, Jan Homan, the bridge office there, for them being actively involved in the design work up to the implementation or construction work. So from my side, as an owner of the asset for the area, I really appreciate all those contributions, and I'm sure we'll do the same in the remaining projects that we're going to embark on. Thank you.